Okay, ready?
Yeah.
Okay. So today's presentation is on hybrid vehicles and the past, present, and future dealings with hybrid vehicles and what we are to be expected with here in the next 100 years, if we want to look at it that way. So to first start off, we need to ask ourselves, what is a hybrid vehicle? I know hybrid in the agriculture business is taking two seeds, putting them together, or if you take kind of a tree and graft a tree together, that's what we call hybrid, something that wards off, bugs or whatever. But in a vehicle, a hybrid vehicle basically is, examples of two hybrids are when we take two power sources and put them together. So a hybrid vehicle in this instance would be like a diesel engine, and then we would take an electric motor and actually bolt it to the back of the engine for a power assist is what they would call it. And actually would run. So there's three different types. There's actually more than that, but this is just some of the examples I could find. Diesel, electric, nuclear, and electric, and gasoline. And gasoline's the favorite in what we use today, but some of the examples of nuclear, that's something that they actually built back in the 60s. They built one car, Chrysler built it, and scared everybody to death because they thought that it was going to have a meltdown. So they quickly hatched that one. So there's just kind of examples, but it's anything that is two combinations, as long as you have gasoline or diesel or anything, would classify as a hybrid. Now, in a hybrid vehicle, you have a structure for the hybrid vehicle. As soon as my PowerPoint comes up. The two power sources found in a hybrid vehicle may be combined in different ways, either parallel or series. And what I mean by parallel, it would be either the engine can run by itself, or the electric motor can run by itself. So that is a parallel circuit. The series is when they both combine and come together and actually run. So the electric motor and the engine simultaneously spin at the same time, and the electric motor is supposed to assist and help the gasoline engine. So when you start taking off, and I know in a Toyota Prius like yours, it's basically, it can take off without the engine running up to a certain speed, and then the engine kicks on, and it's all built in to run that way. There's also, either one will allow the gasoline engine to shut down when it's not needed. So in the hybrid structure, you can run on electric motors only. You can run on just the engine itself, or if it has the capability to run electric, at some point it will kick the engine on and charge the batteries as it goes. Here's kind of a typical structure of kind of a elementary diagram, but here's your wheels, electric motor, and your gasoline engine here. So this just kind of gives you an idea, and all these are battery packs and your inverters and everything that goes along with the electrical system is all in this quadrant. Everything goes along with the gasoline engines over here, and what they don't show is maybe like a gas tank. So if they added the gas tank, that would give you a better description. But as you can tell, they both connect together and spin the wheels and run the drivetrain. Electric motor designs, for the most part, this electric motor is nothing different than your ceiling fan that you have running in your house. Identical. Everything has a stator, has a rotor, has electricity running into it. On this one, the engine would actually come and bolt in on this side. The electric motor is here, and then your transmission would be over on this side. So if you select a gear, most of them are automatic. If you have an automatic transmission, if the computer says or you demand to have electric run the engine, this would kick and start spinning. No different if we flip a switch on and the electric fan starts to operate. The nice thing about electric motors is they're kind of like assists. So if you ever want to get up out of a chair on your own, you're almost like an engine. But if somebody comes behind you and picks you up and helps you up out of the chair at the same time that you're doing it, then that is what they call an assist or a hybrid, an extra power or extra little oomph, if you will. Now, high voltage is required for these because what's amazing is we run at a very high voltage, which we'll cover here in a second, but power for the electric motor is supplied by high voltage nickel metal hydrate batteries. There's also lithium ion that comes in with it, and we'll discuss that in a minute. But batteries for all hybrids are produced by Panasonic EV Energy in Japan. Now, just did some research and found out that they own all the patents for all the batteries for hybrid vehicles. Now, other batteries, not so much. But it was very interesting to learn that, you know, everything that they do and their cutting-edge technology, and they're trying to make the batteries better and better and better and better, and they're doing a good job of it. Voltage ranges from 144 volts to 650 volts direct current. Now, direct current is something that we would find in just this little AA battery. It's what we call DC current, direct current. AC current is what we have in these lights. So if we flip the switch on, we have alternating current that goes through. Now, they run DC current is because it's easily charged and the batteries can last a little longer with DC current because there's less heat that's involved. But the thing of it is, it's 144 to 650 volts, equivalent to probably 900 to 1,000 volts coming out of your lights. We only run 110 volts here, and our air conditioning units or something that's high powered, or our electric ranges runs 220 AC volts. Our cars are more powerful than our houses right now. And if you look back, you can, or anybody that has an inverter, you can hook up to your battery pack and you can run your house off your car if you want for emergencies. Couldn't run much, but you could run some. High voltage wiring may be color coded, so the problem with hybrid vehicles is you have car crashes or mechanics working on it, then we have to somehow distinguish what this high voltage is somewhere. So they color coded it, orange, blue, and yellow. And that just allows someone to know if they see an orange code or blue or yellow, that just stop. We gotta do a proper procedures as far as to go into it. Batteries vary in design, however, all incorporated individual cells connected one to another. We'll get into that here in just one second. Our color code, if you look here, here's some orange wires. Sometimes if you see the smaller connectors, that doesn't mean it's high power, it just lets you know that it is part of the hybrid vehicle. Here's orange, 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 and they have this one here is orange. Whenever we see red, we typically think of power. Well, in the automotive world now, if you see orange, you have to think high voltage, don't touch, don't be probing it, don't touch it, unless you're supposed to. Battery types. There are actually 3 different battery types that we're using now. Nickel metal hydrate batteries is exactly what you find in your flashlight today. D-size batteries. If you would take, and this is 1.5 volts per cell, and what they're doing is they're hooking them together, end for end. So if we hook it together and we get 3 volts, and you keep doing that, and you get your battery pack to the point where it is probably, I don't know, 12 inches tall by 30 inches wide, and we've hooked roughly 400 of these together, and we can come up with a pretty good size voltage. But that's exactly what they use in most, and I know in the Toyota Prius, this is it. The other style of batteries that they are using is lithium ion. Kind of examples of lithium ion nowadays is now you're getting all your cordless using lithium ion. All cell phones now are using lithium ion, and the nice thing about this is lithium ion. This is roughly 5 volts. This is 1.5. This will take a charge multiple times. This cannot be charged more than maybe within 5 years of its life. You keep charging this, this depletes. You keep charging this, it just kind of remains. So they're making them smaller, better, and more powerful, and they're doing away with the nickel hydrate for the most part. The other style is the old school lead acid. That's the battery that you just find if you pop the hood and you have a battery sitting there. It's filled with sulfuric acid, and it's a chemical reaction. You can charge it, but you cannot go above a certain voltage. You go above 18 volts, it starts to swell the battery, and it can't handle very much. They used a lot of these back in earlier days just to run electric vehicles. So here's a typical battery pack. And if you see here, right here's 2 D-size batteries that are put together. So equivalent to this. So imagine there is 2, 4, 6, 8, 10. There's probably 12, 20. in this little pack, and this is one quadrant of probably 12 quadrants that are put together in order to create a battery pack. This here is a lithium-ion battery pack. If you notice the size of these, significantly smaller. It can handle more of a charge. This cannot handle too much of a charge. Lithium-ion, you can put roughly 900 volts to 1,000 volts into it to charge it. This, the old nickel hydrate, you can probably charge it at 300 to 400 volts. You can't do a sudden surge into it. So what I need you guys to do is think back the first time you ever saw a hybrid. Do you remember what year that was? And the next question you need to know is, how long do you think hybrids have been around? Because I think this might surprise you. Hybrids have been around since 1901. Owner Porsche, and you have to remember the Porsche name because it is the cars that we have today for Porsche. Hybrid was the first gasoline hybrid automobile in 1901. These guys basically put it together and drove it around. I think it had a range of like, I don't know, 20 miles at 6 miles per hour. So the only thing that, and doing the research, the only thing that was lacking with this was the battery capabilities. And even though today that's something we'll cover in the future, that is something that we still deal with on a day-to-day basis, is our batteries. This is just kind of some information. 1899, Piper in Belgium introduced the vehicle with under-seat electric motor and gasoline engine. It used an internal combustion engine to charge its batteries and cruise on both motor and accelerator to climb a hill. So they basically had the engine that was underneath charging the batteries, and if you had to climb a hill, it would kick both in and run up, and they run it off a pulley system. Some of the other ones in 1900, 1901, 1905, and I could have gone through and kept printing more and more. And we died off in the 20s, and probably back into the 50s and 60s we came back out and died again until the early 90s, and then it started its upswing to what we have today. So, who's making hybrids today? Get all these up. Just all the manufacturers. We've got Honda, Toyota, Ford, Mazda, Saturn, Lexus, Mercury, Dodge, General Motors, and we should have Nissan here. So this is everybody that is actually producing them right now, currently in 2003. So what's in store for the near future? These are automakers that are going to be making them here in the within the next 5 years. The minivan is coming out with hybrid. Chrysler, Cadillac, Dodge, Porsche, BMW, Hyundai, and Mercedes is all projected to have these within the next 5 years. Now, an interesting article to read is, this is what's next. Since the battery packs are getting smaller and smaller, they are now getting to the design where they can allow the engine and then put electric motor, because the motors are getting tinier and more efficient, to put them in motorcycles. So that is something that they want to come up with next. I kind of hope they do. I like motorcycles. Now this one's just a future design. It has an electric motor in the back for a duct fan. Of course, I fly airplanes, so this is my personal favorite. But anyway, the design is more of, when I put into the computer hybrid vehicles, you're taking manufacturing hybrid from engineers, and the design is all coming together. So hybrid doesn't necessarily mean electric motors and gasoline engines together. It means concepts of what's going to be coming in the near future. Future designs, the only thing holding us back is a battery. According to every research that you ever look, it is a fact that our battery packs are improving, but they need to be better and better and better. And once we get to a certain point, then we will no doubt have cars that's probably somewhere that looks like this and probably have ranges of thousands of miles. So with the summary, you should now understand that hybrids have been around for a while, at least 100 years plus. The hybrid structure, everything that's inside of a hybrid, present-day manufacturers, who's producing them today, and the future of hybrids, and what we expect and what's going to happen here in the next 100 years, because if we've come this far for 100 years, what's going to happen in the next 100 years. Thank you for your time.
Very very, very good.
Can we move now?
You can move.
Mr. Bond, that was very, very good.
That was, really, it was, yeah.